Hello everyone, so we have made it to the very last lesson of the geometry curriculum. This is 9.11, which is all about the effects of changing dimensions on a shape. Like for example, if the dimensions of a solid are multiplied by a scale factor of a, then the surface area is a squared times the original surface area, and the volume is a cubed times the original volume. So remember, dimensions just refers to like the length or the width or the height. And if you multiply the dimensions by something, that's going to make a change to its surface area. And this is how we find what the new surface area would be. So next to all these surface area examples, let's write a squared because that's how we're going to find out what the new surface area would be. For example, number 1 says, if the dimensions of a figure are doubled, how many times larger will the surface area be? Well, each dimension is multiplied by 2. That would be our A, and we're going to square that. So 4, which means that the surface area would be 4 times larger. Number 2 says the surface area of a figure is 62 centimeters squared. If the dimensions are multiplied by 5, what would be the surface area of the new figure? So we know that the surface area originally is 62. Each of the dimensions are multiplied by 5. So we have to take 5 squared to know how many times larger the surface area will be. 5 squared is 25. So the new surface area is going to be 62 times 25, which is 1550 centimeters squared. Number 3 says the surface area of a figure is 736 inches squared. If the dimensions are multiplied by 1/4, what will be the surface area of the new figure? So if you're multiplying something by a fraction, by 1/4, it's really getting smaller. So what we're going to need to do is take our 1/4 and square that, just like up here. That's our little guide for right now. 1 squared is just 1, and then 4 squared is 16. So this is 1/16, and we're going to multiply the 736 times this. So 736 times 1/16. And that's going to be the new surface area. That would be 46 inches squared. So this would be the answer. Number 4 says cone A is similar to cone B. If cone A has a surface area of 1422 kilometers squared and cone B has a surface area of 158 kilometers squared, how many times larger is cone A than cone B? So we need to figure out what this is. This is talking about their surface area. So if we divide these, take 1422 over 158, that gives you 9. So that means that the surface area of cone A is 9 times larger than the surface area of cone B. It's asking how many times larger are cone A and cone B, like their dimensions. So if you remember that if we want to undo something to go from the surface area to the scale factor, you would do the opposite. So instead of taking 9 squared, we would take the square root of 9, which is 3. So the answer here would be 3 times larger. All right. So with volume examples, the guide is A cubed. So let's do number 5. If the dimensions of a figure are multiplied by 4, how many times larger will the volume be? So we're just going to take the scale factor, which is 4, and cube that. 4 cubed is 64. So the new figure is going to have a volume that's 64 times larger. Number 6 says the volume of a figure is 110.5 feet cubed. If the dimensions are doubled, what will be the volume of the new figure? So doubled means multiply by 2, so we would take 2 cubed, that's 8. We're going to take this original volume and multiply that times this number, 8, to find out what the answer is. 110.5 times 8 is 884 feet cubed. Number 7 says the volume of a figure is 972 meters cubed. If the dimensions are multiplied by 2 over 3, what would be the volume of the new figure? So we're multiplying by 2 over 3, so let's take that and cube that. So it's like you're cubing each of the numbers. So 2 cubed is 8, and 3 cubed is 27. And we're going to multiply this times this. 972 times 8 over 27. Your calculator can find the answer for that. That would be 288 meters cubed. So number 8 says that solid A is similar to solid B. If the volume of solid A is 21 inches cubed and the volume of solid B is 36 inches cubed, how many times smaller is solid A than solid B? So this is a lot like number 4 from above. You want to start by dividing these two numbers, and that will give you kind of like the volume ratio. So 45/36 over 21 is 216. So 216 is our volume ratio. If we want to work backwards to find out what the scale factor is, you would just take the cubed root of 216. The cube root of 216 is 6, so solid A is 6 times smaller than solid B. So let's go on to the next page where it talks about what happens if you only change one dimension. Changing only one dimension means that the figures are not similar anymore. So remember, we've talked about similar solids, and that's when all the dimensions are proportional or have equal ratios. Therefore, we need another strategy. In this situation, choose test values, calculate both the old and new surface area volume, and then compare your answers. So let's look at some examples. All of these will kind of help you with the homework. How many times larger is the volume of a cylinder if the height is doubled? So we're thinking about volume of a cylinder and only the height has been doubled. So let's remember our formula for volume of a cylinder. That volume is pi r squared times height. So we're not working with any specific measurements. It's not like we have a diagram. They didn't tell us what the actual height would be. So we choose our own test values. So we need to choose a value for R and a value for H. I'm just going to say go with the easy numbers. So R could be 1 and height could be 1. So if the volume of a figure or a cylinder with a radius of 1 and a height 1 would be pi times 1 squared times 1. Pi times 1 squared times 1. Everything times 1 is just the same thing, so the volume would be pi. What happens now if we double the height? So in our new figure, R is the same, but now height is 2. So the new volume is going to be pi 1 squared times 2. So the volume was pi times 1 squared, pi times 1 is just pi, and then that times 2. You have 2 pi. Notice how this is our new volume, this is our original volume. We can divide these to find out how much bigger it is. This cancels out. You're left with 2. So the new figure, after the height is doubled, has a volume that is 2 times larger. Okay, number 10 says, how many times larger is the volume of a square pyramid if the base edge is tripled? So let's think about the volume of a square pyramid. volume of a pyramid is 1/3 times area of the base times height, remember? And the area of the base, because it's a square, the base, it would be side squared. So let's pick out some test values for each of our measurements, S and H. So because that is our base edge, that's like the side of that square. So that's why we need to define what that S would be, or a base edge. S is just going to start off as 1, and then our height can also start off as 1. So the volume would be 1/3 times area of the bases as squared. So let's do 1 squared, and then times height, which is 1. So the volume, when you multiply 1/3 times 1, you just get 1/3. And then what happens if we triple the base edge? So now our S is going to be 3, and our height is still going to be 1. So the new volume would be 1/3 times 3 squared times 1. So if you take 1/3 times 9, 1/3 times 9 over 1, 1 times 9 is 9 over 3. 9 divided by 3 is 3. So our new figure has a volume of 3, and we want to know how many times larger is that from the original one. So you take 3 divided by 1/3, and you can just type that in the calculator. That would be 9. So the new volume is 9 times larger after tripling the base edge. Number 11 says, how many times smaller is the surface area of a sphere if the radius is multiplied by 1/2? So surface area of a sphere has its formula. That's 4 pi r squared. All we need to know is the radius. Let's just pick a value for our radius, something that can be easily halved. So 2 would be a good number. So what would the surface area be with a sphere that has a radius of 2? 4 pi times 2 squared. 4 times 2 squared. 2 squared is 4, so 4 times 4 is 16. So you're left with 16 pi. And if you take the radius in half, the new radius would just be 1. So if you find out what is 4 pi times 1 squared, 4 pi times 1 squared, 1 squared is 1, so 1 times 4 is just 4, you have 4 pi. And then the last thing is to divide them to see how much bigger or smaller it is. So 16 pi over 4 pi, 16 divided by 4 is 4, and these pi's cancel out. So the new sphere has a surface area that's 4 times smaller. Okay, number 12 says, how many times smaller is the surface area of a cube if the side length is multiplied by 1/4? So the surface area of a cube, there's the 2L times W plus 2L times height plus 2W height. That's for like a rectangular prism, but when you have a cube, all the sides are the same. So one other way that we can write the formula is like this, 6x squared. So the side length is going to be multiplied by 1/4. So we want a number that when it multiplies by 1/4, it's still going to be a nice number. So the test value for our S is going to be 4. And then we can find the surface area of that. It would be 6 times 4 squared. 4 squared is 16. 16 times 6 is 96. And then when you multiply the side times 1/4, you're just left with 1. So the new surface area would be 6 times 1 squared, which is 6. Then divide those numbers. 96 divided by 6 is 16. So after multiplying the side by 1/4, you end up with a cube that has a surface area that is 16 times smaller. And the last one. How many times larger is the volume of a cone if the radius is multiplied by 6? So volume of a cone is represented by 1/3 times pi r squared times height. We're going to multiply the radius by 6. So we can pick anything for our radius and our height. Let's just pick 1 for each of them, because that's going to be easy to find what the original volume is. 1/3 times pi times 1 squared times 1. So we basically are multiplying the 1/3 pi times 1 times 1. So you just have 1/3 pi. And then what if we multiply the radius by 6? The new radius would be 6, and the height would stay the same. So we would do 1/3 times pi times 6 squared times 1. So 6 squared is 36, and if you take 36 times 1/3, that's kind of like doing 36 divided by 3. 36 divided by 3 is 12, so you have 12 pi times 1, which is just 12 pi. And now we have to divide these to see how many times larger the 12 pi is from the 1/3. So 12 pi divided by 1/3 pi. When you type this into your calculator, you want to make sure you put parentheses around each of these just so that it doesn't mess up your order of operations. That comes out to 36, so it's 36 times larger when you multiply the radius by 6. And that's it. So that's how you would figure out the effects of changing dimensions on a surface area or volume of a 3D shape.